It says some polynomials will not factor, so they are considered prime, just like the number 7. Now we know 7 divides by 1 and 7, right? But does it divide by any other numbers? No, it doesn't break apart any further. So we call it a prime number. So take a look at number 1. If I try to do an 8 times c here, so I'm talking about the factors of 20 that add up to 3. Does that work?
No.
No. So we would call this a prime polynomial, I should say. It doesn't break apart. So that's your answer. X squared plus 3x plus 20. Just like if I asked you to do a factor tree with 13, can you break that apart? No. So 13 is a simplified number. It can't break down any further into factors. Yeah.
So would you want us to put prime or like?
You would just leave it as this. Yeah.
So don't write
Basically, it's understanding. The hardest thing about factoring is knowing when to stop. Because sometimes you factor out a GCF, but what's left behind factors. Or you'll factor and you're going to see here in a little bit one that goes on for a minute. But the hardest part is knowing when to stop. Okay, so if you came across this, you would stop right there. Okay, it doesn't factor, so just leave it as it is. Same thing with number 2. Are there any factors of -5 that add up to 0 x's? No, that's not a perfect square, right? And in order to add up to 0, it has to be the same number. One's positive, the conjugates, right? And that doesn't work. So it's just a prime polynomial.
Minus.
Yeah, so we have a difference, meaning subtraction of 2 perfect squares. Now, some ones over here we have commonly seen. These are some ones that we'll see a lot. So x squared minus 9 happens a lot. Now you'll notice, look at our little formula. A squared minus b squared. It's not going to be written as b squared, but it's telling you that 9 is a perfect. So how could you write this? X squared minus 3 squared, right? That's basically what it's showing you. It's something that has been squared, and that's 9, right? So some other ones that we'll see a lot of. You know all your perfect squares, but x squared minus 49 would be what? 7 plus 7 minus 7, right? Adds up to 0. X squared minus 64. X squared minus 100. There can even be a number in front as long as it's a perfect square. So for example, if I had 4x squared minus 9, is 4 still a perfect square? Yeah, it would be 2x times 2x would be 4x squared, right? So this is still a difference of everything perfect squares. Okay? So, we've already done these, so this should be easy. X squared minus 25. How's that going to factor?
X plus 5, x minus 5.
Yeah, it's basically a bottoms up. It's just 0 is in the middle. X is 0. So plus 5 minus 5 cancels out. That's why there's no x's in the middle. Okay, now number 2. Is 3 a perfect square?
No.
Is 48 a perfect square? Is x a perfect square?
No.
No. So what do you think we need to do first? Do what? Greatest common factor. Yep, what did both of those terms divide by? 3? Yeah, and they both have 1x. So 3x. And then left behind would be a y squared in front. Minus 48 divided by 3 would be 16. Now, like I said, technically we just factored, right? We pulled out the greatest common factor. We did a factoring just now. But the hardest thing about factoring is knowing when to stop and when to keep going. What do you notice about what was left behind after doing one round of factoring, the GCF?
Perfect square.
There was a perfect square left behind, a difference of perfect squares. So we end up getting y plus 4, y minus 4. And that would be your answer. Obviously, y cannot break apart any further. So at that point, they're all prime. Y plus 4 can't break apart any further. Y minus 4 can't break apart any further. That's the answer. Okay, that brings us to our next one. What does sum mean?
Addition.
That sign changes everything. Because let's look at it. Let's try and do a bottoms up. So what factors of 25, now notice it's now a positive 25, right? Up here, it was like a negative 25. So what factors of positive 25 add up to 0? Do 5 and 5 add up to 0? Negative 5 and negative 5 is negative 10. It's going further negative. But negative 5 and 5 would be negative 25. We want positive 25. So in a way, it's prime. It doesn't factor using bottom set. But what do you notice we can do? A plus bi, a minus bi. And I'll show you why this happens. So it's very similar to a difference of squares. It's still x plus 5, x minus 5. But what do I have to attach on? An I.
No, not again. Not that.
It's not going away. We're going to have imaginary stuff all year.
Well, I mean, it's
So this is good review.
Okay, so we're done.
Yeah, that's it. That's all there is to it. That's as hard as it gets.
Okay.
But I want to show you why this works. So if I FOIL this out, what's x times x? X squared. Now what do we know always happens with the middle two terms of conjugates? They're always going to cancel. So you can see here we have minus 5i plus 5i in the middle. So now let's just FOIL the last two terms. So what's 5i times negative 5i?
Negative 25.
Negative, right? Positive times negative. 5 times 5 is
I squared.
25i squared.
Oh my god. And then that's
And then it goes down to positive.
And you
And
can put
remember,
cycles.
I squared saves the day because I squared is actually negative 1. You remember that? I squared is negative 1, which means this actually ends up being plus 25.
Wow.
So that's how we can cause two factors to add up to a positive number, but cancel out to 0. Conjugates that are imaginary. We kind of put two concepts together. So now do number 2 on your own real quick. Sum of perfect squares. We do 1 plus, 1 minus. Those are called conjugates, right? So I'm just following this little formula right here. And then what times what is 9x squared? 3x. Yeah, that's what's going to go in front. Because if I FOIL this out, 3x times 3x is 9x squared, right?
Yeah.
So it's basically the square root of these numbers, right? And what's the square root of 100? 10, but it's a sum. Anytime it's a sum, we have to attach an I to that number. That will flip the sign for us and make it a sum of squares. That's your answer, that's it. So this is called a sum, meaning plus, of perfect cubes. They're things being cubed now. And I will tell you, I think this is the easiest thing we do all year. Just straight up. This is the easiest thing we do all year. Because all you have to do is figure out what's being cubed, and then you just have to throw it into a formula and you're done. Like I promise you this will be easy. So so notice, our formula is a cubed plus b cubed. But this one's a. In other words, what is being cubed? So look at our first term here. What is being cubed? X. And our second term is the b term. It's telling us this is being cubed. So what number is being cubed? In other words, what's the cube root of 64? If you're not sure, put in your calculator. 4, right? 4 times 4 times 4, right? So what is being cubed? What is being cubed? Figure out your a and your b. And now all you have to do is fill it into this formula. So what does it tell me to do first?
X plus.
A plus b, which is x plus 4. And then we do a squared. So what am I going to put in my answer?
X squared.
X squared minus AB, good, is 4 times x, so 4x, plus 4 squared is So you can actually square it, and that's your answer.
Oh.
That's hard.
Will that formula be on the test?
Yep. No, you'll have to have this memorized.
Oh,
Alright, no.
are you being serious?
You'll see it's really easy to memorize. By the end of this lesson, you're going to already have it memorized. Now notice what was left behind. 3 terms, and it's a quadratic, right? Usually those break apart with bottoms up, but it never will. That's why that's what makes it so easy. After you do the sum of cubes formula, you're done, always, no matter what. If you try to do a bottoms up here, what factors of 16 add up to -4? They don't. 8 and 2 would be 6 of some kind. 4 and 4 would be 8. -4 would be -8. It never works. So you always just circle your answer and you're done. That's all there's to it. Okay? So let's do one more of those together. So look at my first term. What times what times what is 8x cubed? 2x. Does everyone see that? 2 times 2 times 2. In other words, the cube root of 8. And then, Brayden, what is the cube root of 27? What times what times what is 27? 3. Once you have that, you just throw it into your formula. So our first parenthesis is a plus b, which is going to be 2x plus 3. Then what do I need to do to my a value? Square it. So what's going to be here? 4x squared or is it 2x squared?
2x.
A is 2x, right? We need to square a, which is 4x squared. You have to square both numbers, right? 4x squared. Minus, I'm just following the formula. I put the sign that it tells me to put. That's all there's to it. The signs will always be plus, minus, plus. Good. A times b would be 6x plus b squared is 9. And that is your answer. This quadratic that results from this formula will always be prime. It never breaks apart. So once you're done with that, circle it and you're done. What's the only difference between sum of cubes and difference of cubes? The plus sign and the minus sign. And now what do you notice is the only thing that changes from here to here?
Minus,
Plus.
plus, minus.
This is plus, minus, plus. This one's minus, plus, plus. Now notice the sum starts with a sum. And the difference starts with a difference. The only thing you have to remember is the other 2 signs. Okay, so it might just take a little bit of memorizing, but you'll do it enough that it'll be pretty easy. Okay, so same concept. Don't pay any attention to the negative sign. I'm just looking at the numbers on each side. What times what times what is x cubed? X. What times what is 27? 3. That's all there is to it. Then you just, so you can do a binomial and then a trinomial. Right? 2 terms and then 3 terms. And then the signs are always going to be right there. So this one's going to go minus, plus, plus. No matter what. And then you just throw in your a and your b. So x minus 3, x squared, 3x, 9.
Yay.
There is your answer for 2. So sometimes a polynomial looks like a quadratic, but it's of a higher degree. So see how this still is 3 terms, but how is this different than a quadratic? Typically, our quadratic is ax squared plus bx plus c, right? With the exponent of 2. So what's different?
You got some higher exponents.
It's a way bigger exponent, okay? But it says as long as the largest degree is even, 6, right? The next exponent is half of that, and the last number is a constant, it still can factor with bottoms up. So we factor out the GCF. Now inside, A is what? 1, B is 7, C is -8. So we break our 6 apart into 3 and 3. So you can see here we had a sum of cubes we factored as here. We had a difference of cubes that we factored as here. And that is your final answer.